Hello everyone and welcome back to the series Pins of 8085 Microprocessor. Today we are in the part 4, that is the final part. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, today from the pin diagram of 8085 microprocessor, we are going to learn about the pin number 34. Then we will learn about the pins 29 and 33. Thereafter, we will learn about the pin number 35. Then we will learn about the pin number 37. And finally, we will learn about the pins 38 and 39. So let's begin. Now before we learn about the pins today, as usual, let's quickly revise the pins that we have learned so far. Now in 8085 microprocessor, the pin number 1 and 2, that is X1 and X2, these two are responsible for the frequency of the microprocessor, that is 3 MHz. Coming to the next two pins, pin number 3 and 36. Pin number 36 is the reset in pin. Now this pin is used to reset the 8085 microprocessor, whereas the pin number 3, which is the reset out output pin, this pin is used to reset the peripherals connected to the 8085 microprocessor. Then we have the pins 4 and 5. These two are used for serial input and output data. Then we have the pins 6 to 11, the interrupt pins. At pin number 6, we have the trap interrupt. It is the non-maskable interrupt and generated by critical situations like power failure and hardware malfunctions. Then we have the restart interrupt pins. These are used by the software instructions. Thereafter, we have got the interrupt request pin, which is used by low priority interrupt devices, that is keyboard and mouse. And for both the restart and the INTR interrupts, the 8085 microprocessor will have to generate the interrupt acknowledgement active low signal so that these interrupts can be serviced. Then comes the pins from 12 to 19. These are generally used for data bus. Now whether through these data bus, the data will be written or will be taken as input, that will be decided by the pins 31 and 32. Pin number 32 is read bar and pin number 31 is WR bar. Both of these pins are active low pins. So, whether the microprocessor is either interested in reading or writing, that has to be conveyed by these two pins. Remember, since these are active low pins, in order to state whether it is reading or writing, at least one of them should be 0. If RD bar is 0, and at the same time if WR bar is 1, it will mean the microprocessor is going to read. And if WR bar is 0 and at the same time RD bar is 1, it will mean the microprocessor is interested in writing. Then we have the pins 20 and 40. Pin number 40 is for the 5-volt power supply and pin number 20 is used for the ground connection. Coming to the next pins from 21 to 28, that is A15 to A8, these lines are used to send out the higher order byte of the address bus, that is, the most significant 8 bits of the 16 bits of address bus. And at the same time, via the lines 19 to 12, these pins will be used to send out the lower order byte, that is the least significant 8 bits of the 16-bit address. Now whether these lines are carrying data or address, that will be determined by the status of the pin number 30, that is ALE. In the previous session itself, we learned that if ALE is high, these pins are going to carry the lower order byte of the address bus. On the other hand, if it is low, these pins will carry the data. That is, they will work as the data bus. So that's the functionality of ALE or address latch enable. So that was the quick recap. Let's now learn about the pins of this session. So we will start off with the pin number 34, that is IO/M bar. Now we already know the microprocessor can communicate with both the memory and the input-output devices. However, in order to communicate with the input-output devices, the microprocessor is going to use the input-output ports. Now if you remember, when we were talking about the data bus, we learned that the data bus can be used to fetch program codes from the memory. Because we can only store the program codes inside the memory, we can't really feed the program codes to the microprocessor via the input port bit by bit. However, when it comes to data, data can be either retrieved from the memory or can also be written to the memory. Additionally, the microprocessor can also receive data from the input port, as well as it can produce the data to the output ports. So the question is, which of the devices, whether it is I/O device or the memory the microprocessor is communicating with, will have to be determined whenever the data transmission is in progress. In that regard, the pin number 34, that is the IO/M bar, comes in handy. Notice, pin number 34, that is IO/M bar, is actually an output line. Now we already have learnt about the WR bar and RD bar lines. Along with these, we will have to consider IO/M bar pin as well to determine the functionality. Let's now understand the different functionalities based on the sequences of these three pins. Now if IO/M bar is 0 and at the same time WR bar is 0 and RD bar is 1, what is going to be the function of the microprocessor? Notice, we are having 0 in the line IO/M bar. Now since it is 0, it will definitely affect M bar. That is, we are communicating with the memory now since memory has the bar on top of it, so it is active low. Now coming to WR bar, it is 0. So now the microprocessor is interested in writing. However, since RD bar is 1, that is, it is turned off. Therefore, the functionality is going to be the microprocessor writes to the memory. Therefore, if the microprocessor wants to write to the memory, the combination of these three pins are going to be 0, 0, 1. Now if IO/M bar is 0 and at the same time WR bar is 1 and RD bar is 0, what will be meant by this? Well, we are communicating with the memory, and since it is 0 and at the same time WR bar is 1, therefore the microprocessor is interested in reading now. So the microprocessor reads from the memory. Now if IO/M bar is 1 and at the same time we have this configuration of both WR bar and RD bar, that is, WR bar is 0 and RD bar is 1, what will be the functionality in that case? Now this pin is 1, so we are not referring to the memory, however, we are referring to the output port. Now why exactly output port? Because WR bar is 0, that is, the microprocessor is interested in writing. And at the same time, RD bar is 1. So this is inactive. Therefore, the functionality is going to be microprocessor writes to the output port. Finally, if the IO/M bar is 1 and at the same time we have this combination for both WR bar and RD bar, this will mean the microprocessor is not interested in writing anymore. It is interested in reading, and where it should be reading from? Well, the input port. So the functionality is going to be microprocessor reads from the input port. Therefore, along with WR bar and RD bar, if we also consider this particular pin, these combinations will determine the functionality of the microprocessor, whether it is communicating with the memory or it is communicating with the input-output port. So that's all about the pin number 34, that is IO/M bar. Remember, when it is 0, we are communicating with the memory, and when it is 1, we are communicating with the input-output port. Let's now learn about the next pins, pin number 29 and 33. These are the pins S0 and S1. Notice, these are output pins. Now S0 and S1, it stands for status signals. These actually indicate different phases of instruction cycle. Now regarding instruction cycle, we are going to learn in details in a different lecture. For now, just try to understand this. In order to execute any instruction, the instruction will have to go through different phases of the instruction cycle. That is, the execution of instruction is not only a single phase, it is an instruction cycle altogether. And the microprocessor is going to indicate about the different phases via these two status lines. Now, as I told you earlier, the instructions or the program codes are to be stored inside the memory. However, if we are going to execute those instructions, we can involve both memory and input-output port. And the reason for that is, after executing one instruction, the instruction execution may lead to generation of some output or taking some input. In that case, we will have to consider both the input-output ports and the memory. So, the lines S1 and S0 will also be combined with IO/M bar pin, that is the pin number 34, in order to determine the machine cycle. Let me show you the different machine cycles based on these three pins. Now, if IO/M bar is 0 and at the same time both S1 and S0 is 1, this will mean the machine cycle opcode fetch or OF. Although we will be learning about the different machine cycles of the instruction cycle in a different lecture, let me briefly introduce them to you right now. Now, opcode fetch means fetching the instruction which is inside the memory, and that's the opcode or the operation code. And this is the reason why IO/M bar is 0, because the opcode or the instruction is going to reside inside the memory only. Thereafter, with the combination 0, 1, 0, the machine cycle we are going to have is memory read or MR. Try to understand this. IO/M bar is 0, so the microprocessor is clearly reading from the memory, and this cycle is used to read data from the memory. Notice the combination of S0 and S1, it is 1 and 0. Thereafter, if we have 0, 0, 1, that is if IO/M bar is 0, and at the same time S1 is 0 and S0 is 1, it will specify the machine cycle memory write or MW. Since IO/M bar is 0, so the microprocessor is communicating with the memory. Additionally, S1 being 0 and S0 being 1, this is going to specify memory write. Coming to the next combination, if we have 1, 1, 0, it indicates IO read machine cycle. Notice we are having 1 in the pin IO/M bar. That is, the microprocessor is now communicating with the input port. Now, if you focus on this particular combination of S1 and S0, it was memory read since it was 0 in IO/M bar. However, S1 was 1 and S0 was 0. Now, in this particular combination also, we are having the same sequence of S1 and S0, and that specifies reading. Coming to the next combination, we have got 1, 0, 1. Since this is 1, so clearly the microprocessor is communicating with the output port. And if you notice, S1 being 0 and S0 being 1 specifies write. The only difference is we are communicating with the output port now. So, with the same combination of S1 and S0, we are getting the indication of the machine cycle IO write. Finally, if all of them are 1s, it will mean interrupt acknowledgement. So clearly, when the 8085 microprocessor needs to generate the active low signal INTA, the combination of IO/M bar, S1 and S0 all are going to be 1s. Now you might be wondering, what if all of these signals are 0s? Well, in that case, the microprocessor is going to halt. So these are the different machine cycles of the instruction cycle. Don't worry about the details regarding this now. We will learn about them when we will learn about the instruction cycle in details. Let's now focus on the next pin, pin number 35, that is ready. Now ready is an input pin. This particular pin is used to indicate whether an input-output device is ready to send or receive data. Now if ready is 1, that is high, it means the IO device is ready for the data transmission. However, if ready is 0 or low, this will mean for the time being until it becomes high, the microprocessor is patiently waiting. Let me explain how this pin is going to help. Imagine a scenario where an external printer is connected to the microprocessor is still processing the previous print job. In this case, the microprocessor initiates a data transfer. Now, if the printer is ready, the signal will remain high. However, if the printer needs more time, the ready signal goes low. And for the time being, the microprocessor will patiently wait. Once the printer is ready, the ready signal will go high again, allowing data transfer to resume. So basically, the ready signal ensures efficient communication between the microprocessor and the slow peripherals, preventing data loss or synchronization issues. It is just like a polite conversation where the microprocessor waits until the peripheral says, "I am ready," before exchanging data. So that's all about the pin number 35, that is the ready input pin. Let's now learn about the next pin, that is pin number 37 or clock out. Now in the very first session of the pin diagram of 8085 microprocessor, we learned about the pins 1 and 2, that is X1 and X2. And we already know these two pins are responsible for the clock frequency of the microprocessor. Now the microprocessor is supposed to communicate with the external devices. Therefore, it may need the synchronization with the devices as well. For that, the output pin clock out provides a timing reference for the various components which are connected to the 8085 microprocessor. Basically, via this pin, the microprocessor tells the peripherals or the different components to synchronize with it. Remember, this is an output pin. Let's now learn about the next two pins, pins 38 and 39. Now pin number 38, that is HLDA, stands for hold acknowledgement, and pin number 39, that is the input pin, it is hold. Now these two pins are called direct memory access signals or DMA signals. Now honestly, there are various modes of data transfer when it comes to the communication between the microprocessor and the peripherals connected to it. One of the modes is DMA mode of data transfer. We are going to learn about that in details later on. For now, just learn that both pin number 39 and 38 are used for this particular mode. Coming to pin number 39, that is hold, it is used so that the external devices can request the bus access. Now what do I mean by bus access? When hold is generated, the microprocessor is actually being requested by the device which is generating the hold request so that the microprocessor can relinquish the access of the bus, that is the data and the address bus. Remember, it is just a request. Now if the microprocessor wants to release the buses for the devices to use, it will generate hold acknowledgement, indicating that the microprocessor is acknowledging the hold request by the device. Therefore, for the time being, microprocessor is not going to use the bus. Rather, the device which generated the hold request is going to take control of the bus. So, these are all the 40 pins of the 8085 microprocessor. Remember, 8085 microprocessor is a 40-pin dual inline package integrated circuit. It has 20 pins on each of these sides. So in this session, we learned about the pin 34 at first, that is the IO/M bar pin. Then we learned about the pins 29 and 33, that is the status signals S0 and S1. Thereafter, we learned about the pin number 35, which is the ready pin through which the input-output device will let the microprocessor know whether it is ready for the data transfer or not. Then we learned about the pin number 37, which is the clock out output pin through which the microprocessor synchronizes the peripherals which it is connected to. Finally, we learned about the pins 38 and 39. Pin number 38 is hold acknowledgement and pin number 39 is hold request. Hold request will be generated by the input-output device for direct memory access, and if the microprocessor acknowledges it, it will activate the pin number 38. With this, in today's session, we covered the entire pin diagram of the 8085 microprocessor. Alright people, that will be all for this session. In the next session, we are going to learn about the typical structure of the microprocessing unit. So I hope to see you in the next one. Thank you all for watching.